Okay, last page of the notes that we're going to be going over here. Linear transformation. So there's some rules here, and they're all on page 55 of your textbook. So if each observation, imagine there's a list of data like Hank Aaron's home run numbers. If each one of those observations is multiplied by a positive number, let's call it B, then the center and the spread, all of the mean, median, standard deviation, IQR, are all multiplied by B. So if you take a number and multiply it to every number inside the data set, that's the same thing as taking the mean, median, standard deviation, IQR, and multiplying them by B as well. Now this next rule, when adding a number, positive or negative, let's call it A, to each observation and distribution, the center and the quartiles will have that same number added to it. However, it has no effect on the spread, the standard deviation, or the interquartile range. None of the spread is affected by that. I mean, you can look at it one of two ways. Let's say we're looking at spread, like maximum minus minimum. Let's say the maximum of the original set was 22, and the minimum was 12. So that spread would be 10. Okay, now let's say we added a positive number to every number in the set. Let's say we added 5. So the new maximum would be 27. What would the new minimum be? The new minimum would be 17. What's the spread there? Still 10. Those are the same. So adding a number affects where the center would line up because the center would shift. But adding a number would not affect the spread since we're adding it to both the max and the minimum, or both the Q3 and the Q1. So those are the three rules that we have there. All of them are affected by a multiplier, and when you're adding a number, only the center is affected, the spread remains unaffected. And then comparing distributions. Back-to-back stem plots and side-to-side box plots are used to compare distributions of quantitative values. So what we have here is 12 different box plots. We've got a box plot for April, August, December, February, all of the months. So in this side-to-side box plot, we can see, look, these medians are roughly the same with these ones in here. These medians are much lower, and this one's a lot higher than all the rest of them. So we get an eagle-eye view of where the medians are, where the maximums are, the minimums, and we can compare things just by looking at it. This has a lower maximum than most of the rest, and this one too also has a lower minimum. So we can compare medians, interquartile ranges, which are the size of the box, minimums and maximums right on the spot. Now with back-to-back stem plots, here's what we have. Here's a regular one with stems of 9 and leaves over here. So we got 90s, and then we've got 100s, 110s, 120s, 130s, 140s. Well, if we want to form two distinct sets of data, let's say that 93 and 94 came from one set and 98 was in another. So we can put the stem right in the middle, and we can have one set that had 93 and 94, and this other one had 98. This one had 101 and 105. This one had 104. So instead of combining two different sets of data here, we can have our one list of data and a separate list of data and keep them on different sides of the stem and the leaf plot. So we have stems in the middle, leaves from one set, and leaves from a different set. So we can see, okay, this one, see how this shape goes down towards the lower numbers? That's going to be skewed left because the top slants down towards the left out very far and down towards the right not very much at all. This one has a peak way up here and it's sloping down this way, which is to the left as well because it's going down to the smaller numbers. So we have two different sets of data that are separated into two different leaves. Make sure they're on either side of the stem. Also, whenever you're comparing distributions, always remember to use size. You have to talk about the shape. You have to talk about outliers if there are or if there aren't any. You have to talk about where the center is in the distribution, and then talk about the spread. Remember, if it has outliers, then you'll want to use IQR. And if it's somewhat symmetric, you can use standard deviation.